Welcome to AP Calculus AB video for skill number 144. I can find derivatives of inverse trigonometric functions. Period. And the trivia question for today is the capital comes from the Latin word caput, which means what? Here's the French word for capital, chapiteau. Alright, so we're going to start with a quick review of some important things to know. If we wanted to generate the equation of a line tangent to a function at x equals a, we can use the y minus y1, which we'll call f of a, and this is equal to the slope at a, which we'll call f prime of a, times x minus x1, which is just a. So this is very little different, or you could even argue it's the exact same thing as our point-slope equation. So the next important thing to remember is if position is measured by s of t, then velocity is s prime of t, speed is the absolute value of s prime of t, and acceleration is s double prime of t. Or if you wanted to, you could say the derivative of velocity. So those are some important things that we'll get to later in the notes. There is 6 inverse trig functions, and we have to memorize these rules. And these are perhaps the hardest trig rules to remember because they all look very similar. Fortunately, it will probably only pop up maybe once on the AP test, so if you don't commit all these to memory, you're going to be okay, or at least relatively okay. So the derivative of inverse sine is 1 divided by the square root of 1 minus x squared. And remember, we can apply the chain rule to this. So if it was something other than x, we would have 1 minus u squared times the derivative of u. And I won't bother writing these red ones down for all of them, but should know that we can use the chain rule. So the derivative of cosine, inverse cosine, is the negative of that. So negative 1 over the square root of 1 minus x squared. Tangent, we just have 1 over 1 plus x squared. Cosecant, we have negative 1 over x times x squared minus 1. For secant, we have the positive version of that. And then finally for cotangent, we have the negative of our tangent. So you can see that tangent and cotangent are the same with just opposite signs. Similarly, cosecant and secant are the same with just opposite signs. And then finally, sine and cosine are the same with opposite signs. So perhaps this would have been better arranged up here. Anyway, let's apply these rules. I think I start on the next page. Let's go to the next page. Alright, we're asked to find the derivative of the inverse sine of x squared minus 15x. So we're going to let our u for this be x squared minus 15x, which means our du is 2x minus 15. So the derivative of inverse sine is 1 over 1 minus u squared du. So we can substitute that in, and we get 1 minus x squared minus 15x times du, which is 2x minus 15. And I would leave it like that. I would not bother trying to simplify it any. Oops, we need to square that term. Let's make that a clean 2. Okay. Easy to miss these small details, but double check your work. Let's actually apply these derivative rules, because ultimately that's what we want to be able to do, is move past the derivative and actually apply a derivative rule. Find the equation of the tangent line to inverse tangent 2x minus 4 at x equals 2. Well, we first need to remember that the equation of a tangent line is going to be y minus f of a, f prime of a, times x minus a. So in this case we have y minus f of 2 equals f prime of 2 times x minus 2. Now we're going to need to evaluate what is f of 2, so we can stick 2 into the equation. F of 2 is inverse tangent of 0. So inverse tangent of 0 is actually 0. So y minus 0 equals f prime of 2 times x minus 2. So we're going to need to find out what is f prime of 2. So f prime will be our inverse tangent, and the rule for that is 1 over 1 plus, looks like we'll have to use the chain rule, u squared times du. So we have 1 over 1 plus 2x minus 4 squared times du, which is 2. If we evaluate that at 2, we're going to get an answer of 2. So there's our f prime of 2. We plug it in there, giving us a final answer of y is equal to 2 times x minus 2. An inspection of the graph tells us that what we have is the inverse trig function looks something like this. 2 occurs right there, and there's our tangent line. So this is a good thing to practice, as you enter your original function into the calculator as well as your equation of your tangent line to check to see if it works out.
Because you know I'm out trouble. I'm out trouble.
Alright, upon closer inspection of this problem, I need to change a value here. Let's make this 0.25 seconds. Okay, so a particle is traveling on a straight line, and the distance in meters of the particle relative to the start point is given by this function. And we need to estimate the speed of a particle, and we might remember that speed is equal to the absolute value of velocity, and velocity is the derivative of position. So we're going to need to find the derivative of this position. We know that our derivative for cosine, inverse cosine, is negative 1 over 1 minus u squared times du. And in this case, our u is x squared plus 3x. So we're going to have x squared plus 3x quantity squared, 1 minus, and we take the square root of that, divided by negative 1 times du, which is the derivative of our u, which is going to be 2x plus 3. So if we go about plugging these values in the numerator, we're going to get 2 times 0.25 plus 3 times the negative 1 comes to negative 3.5 in the numerator, and in the denominator we're getting the square root of 1 minus minus 0.8125 squared. If we square that and then subtract it from 1 and then take the square root of that, we're going to get approximately 0.58296 in the denominator. So negative 3.5 divided by that answer, and we arrive at a value of approximately negative 6.003. So that's our velocity at time 0.25. The speed is the absolute value of that. So speed is going to be around 6.003 meters per second. Looking back over my calculations, I noticed that this was 3/8. So if we're going to round this appropriately, then we would actually have 6.004. Alright, I checked that on the grapher as well. You can calculate derivatives at a point on a graph, and we found that the derivative was also 6.004, or negative until we took the absolute value. Alright, thank you for watching the video. The answer to the trivia question is the Latin word caput means head, so the capital is the head of the column.